so let's go ahead and I'm going to make a few announcements and then we're going to jump right on in. We have 2 pages that we want to get through today. We're going to do pages 95 and 96 on the review. This is still information that we're reviewing that is from units 1, 2, 3, or 4. Looks like the majority of what we're reviewing today is still from that unit 3. So don't worry, as we get closer to the beginning of fall classes, we're going to be getting into those units 4, 5, and even a little bit into 6, all of the polynomial type stuff. But it's really good for us to have a foundation and just review the basics of how algebra works. I told you last week that we were just like get in, get out, you know, nothing fancy, no games, no fun. We still are going to be a little bit get in and get out today, except I do have an extra credit opportunity that is fun and is very suitable for summer. So if you don't mind, I'm going to go ahead and share my screen and show you inside of ThinkWave. Here we go. All right. If you log into your ThinkWave account and you check the different sessions, you should have a session that's called Summer 2021, and that's where you can find what we are doing to get ready for review here. Mine obviously is the admin side, the teacher side, so it looks a little bit different. But you will see that there was a new assignment put in and it says extra credit opportunity for summer. So clicking on that, here is what it is. The biggest question, the biggest problem, the biggest gripe that math students have, especially in algebra, is like, when am I ever going to use this? This has nothing to do with everyday life. Why do I have to know how to factor a polynomial? And those are very solid questions. I wanted to give you an opportunity to see some of the ways that math is used. This is not quite in real life. This is in Hollywood life, although some of these are based on true stories. So I have chosen 10 different movies that all have something to do with math and its application. And you can, if you want, watch any of these movies as long as you have permission from parents or whatever. They're PG, none of them are R, but there are PG and PG-13s in there. And then, of course, Donald Duck, he's G, I'm sure. But watch the movie specifically to be on the lookout for what kind of math is being used and how do they use math to solve the problems that they have. And then you can send me a message, like you could upload something directly into ThinkWave, or you can send me a message in Slack and just tell me, I watched this movie, this is what I noticed about math and how it was used, and you'll earn yourself 10 extra credit points. So you could do as many or as few movies as you want, but the deadline for getting extra credit for these up here is this August 17th. Because once the school year starts, I don't want you to not be doing your homework, but watching movies instead.
So, question.
Yes.
Hidden Figures is one of my favorite movies of all time.
Oh, wonderful.
So, does that count as the extra credit?
As long as you message me with the application of math that you see in it, sure.
Okay, I'm just making sure I didn't have to rewatch it or anything.
No, if you know it well enough that you can already comment on it, that's great.
Okay.
I also wanted to show you, which is a little bit weird, I shouldn't really be showing you everybody's pages, but I just want to show you quickly, I don't think that the people will care, that you have the ability to input your homework assignments directly here into ThinkWave. And so I had a couple students do that this week. Naomi, you can see over here, she has attached her files. That was her homework. And Sophia, she has attached her files. That's her homework. Once you guys learn to do that, that is going to be very beneficial and very helpful to me because I won't miss your homework and it is always available. And then the other thing, now I flipped over here, I am now on my trying to find your new Slack space. your Slack space has been created, and this is the other place that it's going to be really good to give me your homework or send me messages or things like that. I hadn't loaded it yet because I was fiddling around doing other things, but once I find it here, I will load it and I'll show you what our Slack space looks like, and then we're going to make sure that everybody is good, and we're going to hop over to homework. So it's going to be a 21, 22, and these don't go in alphabetical order for some reason. So if I'm scrolling, you're like, Mrs. Music, you passed it up already. Let me know. 21, 22. Okay, science, ceramics, finance, geography, chemistry, biology. Where's algebra? Literature and love, animals, robotics. Here we are. Berea Algebra 21, 22. Okay, so I'm going to go ahead and load this. There. And I'm hoping that most of you have already gotten familiar with using Slack because you've used it for other Berea classes. If not, and you need a quick primer on how to use it, I would be happy to do that with you separately here. Yes, here we are. So this is our Slack space for algebra, and right now it's super boring, but I will go ahead and load in the homework week by week, so you can download it if you need to. Down here in this part where it is direct messages, once you are in here, then you can direct message me, and I'm going to go ahead and put an invite link inside of our Zoom call, and then I'll email it to you also. But there, I just put the invite into the algebra Slack over there in the chat, so you can take a look at that. And Jonathan, oh yeah, hey Jonathan, Jonathan is here. That is the second place that you can send me your homework. The third preference would be sending it via email. That works too. It just gets a little bit more jumbled. And then I suppose the fourth preference would be you could text it, which my daughter Emma did. Emma is not on the phone call. Oh, no, there you are. Hello, Emma. So that's a possible. And then the fifth one is snail mail. You know, put it in an envelope and send it to my address, but nobody wants to do that, right? Okay, so if you had a problem with your week 1 homework, I should have messaged you separately and told you what problems you needed to fix. And inside of this platform right here, annotate, I'm going to change that so it's not Algebra 1 2020. This is going to be still what we use for this year. But you're going to see that you're going to have a folder. And if you click on your own folder, you'll see your homework if there were things that I needed to comment on for you to fix. So this is a place where you can find detailed notes. But of course, just always contact me if you have any questions. All right. So we are working on this document right here. No, that's not what we're working on. That was Jonathan's homework. Sorry, Jonathan. We are, where is it? Summer review. Okay, we are working on this document right here. The units 1 through 4, comprehensive review. And when we worked in class, I left the annotations of what we had on here. All of you inside of Annotate can pull up the same document that you're looking through during Zoom. So if you were trying to work on your homework and you didn't get something right and you need to fix it, this is a place where maybe you can get some help. It's almost like it's turned into a solutions manual. But let's go ahead and look at what we are doing for today. And so this is page 95. You all should have printed this off in advance, and it is not cheating to go ahead and fill out your hard copy of this homework while we're talking about it all together. As long as you have understanding and you know what you're doing, that's one of the benefits of attending these summer prep sessions, is you don't have to do your homework independently. You can just send in your homework at the end of class, and that's great. I am going to ask you all to call on one another, partly because when I'm on the shared screen, it's hard. I can't see all of your names at the same time, but then also partly because I want you to start interacting with one another, and I don't want to be the only person talking. So, Naomi, you're going to be my first victim of the day. Since I already showed everybody that you had perfect homework, I figured that that was safe. We are looking at problem 8. And the problem with this problem, because I always want to tell you to start with looking at the instructions, is it just says continued page 3. So if we want to see what the instructions were, we actually need to go back up here and see. Yeah, they don't have any other added instructions. You always want to make sure that the category of problems you're working on, you have looked at 2 parts of the instructions. The one part that you want to look at is what is it that they want you to do? And then the second part that you want to look at is how do they ask you to do it? Because sometimes the instructions are very specific about how they would like you to do it. We'll have some of those today. And you might have a preferred method, but if they ask you to use this different method in that particular problem, you need to follow the directions. So, Naomi, looking here at problem 8, the what of what we want to do, here we go, is write an equation. So we are not doing a graph this time, although we are still thinking about graphs and the visual representations of algebraic equations. But it says write an equation of a line that is parallel, that's a key word right there, to the line in number 7. Okay, this is where I needed to go back and see what number 7's line was. So number 7 was y equals negative 5x plus 8. So let me go ahead and write that down. Y equals negative 5x plus 8. And there's not going to be only one answer to this question, because if you think about the graph here, and let's say, for example, that was our line. Well, this one's parallel, 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 this one's parallel. Like, you can go on to infinity making parallel lines on both sides, and they would all have different equations, but they would all be parallel to this particular one. So if somebody comes up with an answer that's different than the one we come up with in class, that doesn't mean that it's wrong. It very well could be right as long as it follows the rules of being parallel. So Naomi, interpret for me a little bit. What does this 8 tell us about the equation?
It tells us where our point on the y-axis is.
Yes, exactly. So this is where the line crosses the y-axis. It's called the y-intercept. And then tell me what this piece of information right before the x tells us.
It tells us what the slope of the line is.
Right, okay. And what is slope? As long as I'm asking you a bunch of questions.
Like the tilt of the line? Or yeah, like,
exactly. Yeah. So if it is a positive slope, had that been a positive number, then you have a line that is tilted lower on the left and higher on the right. This one is a negative slope, and so that tells us we're going to have some sort of a line that is higher on the left and lower on the right. If it's a very steep slope, it looks something like that, almost perpendicular. If it's a very gradual slope, it would look something like that, almost horizontal. All right, so with that piece of information, how are you going to determine what would be a line that is parallel to this particular line, Naomi?
You keep the same slope and you can just change the y-intercept to whatever number.
Exactly right. All we care about is that it has the same slope. Beyond that, we don't care if it's close to this line or a million miles away from this line. So that means this part of information is not essential. This part of information is not essential. This part of information is not essential. All that we care about is the slope. Okay, so Naomi, tell me an equation that's using the slope-intercept form, because we want to practice that. And the slope-intercept form is always going to have the order of y equals mx plus b. Tell me an equation that will be parallel to y equals negative 5x plus 8.
Y equals negative 5x plus 3.
Perfect. Pick somebody else that's in the group.
Diamond.
Diamond, tell me another equation that's different from Naomi's that also would be parallel.
Y equals negative x. Negative 5.
Yeah.
5x plus 5.
Yes, absolutely. So it's all going to be y equals negative 5x plus whatever you want to put there. Any of those that are in that format will be correct answers. That's it. Problem number 8 is done. No calculation required, no figuring, no graphing, just coming up with an equation. Now, because I want to check and see, oh yeah, we have 9 people here. On a scale of 1 to 10, is everybody a 10 in their understanding of problem number 8? 10, Dylan says 10. Oh, and 11. Very good, Garrett. All right, then Diamond, you get to pick the next victim. We're going to go ahead and do problem number 9.
Wait, say it again, you cut it out.
Pick somebody to go next.
Okay. Sophia.
All right, Sophia, looking at what we're supposed to do, again, we are writing an equation, so we don't have to graph, we don't have to figure, we just have to understand how we're going to write our equation. This time, though, we're not looking for a parallel, we're looking for a perpendicular. And our original one, let me write it down here again so we have it for reference, was y equals negative 5x plus 8. So, Sophia, tell me what is perpendicular? What does that term mean and how is it different than parallel?
Parallel is like side by side. Perpendicular is like the opposite, going the opposite ways.
All right, so parallel is like the train tracks. They're side by side, either close or far apart, but they never, ever, ever touch. And then perpendicular is like a cross. So they touch at one point and they're completely opposite. One is one way and the other is the other way. When you have perpendicular lines, they create that 90-degree angle on all 4 sides of the 4 quadrants here, wherever it is that they cross. So when you look at this equation here, what piece of information do you need to pay attention to so that you can create a perpendicular line equation?
You have to pay attention to the slope.
Yes. So it's just like the first one. We don't care about the x right now. We don't care about the y right now. We don't care about the intercept right now. All that we care about is the slope. Now we know that negative 5 is that downward slope because it's negative. If something is going to be perpendicular, like that, is that going to be a positive slope or a negative slope?
Positive.
It's going to be a positive slope. So if you want to have an equation for a perpendicular line, what you need to remember is perpendicular in terms of slope is opposite and reciprocal. So if you come up with a slope that is the opposite and the reciprocal, then you're all set. You're going to be ready to go. So the opposite from one number to another is like the opposite of 3 is -3. The opposite of 10 is -10. The opposite of 100 is -100. Those two things that when you combine them equal nothing. What does reciprocal mean, Sophia? This one.
Like in this case, instead of 5/1, it's 1/5.
Yes. So reciprocal means you change the numerator and the denominator. So this -5 as the slope, if we turn that into a fraction, is the same thing as -5/1. Our numerator was the -5. Our denominator was the 1. To create the reciprocal of that, you just flip them. And so it's going to be 1/5. That's the reciprocal. And instead of it being negative, it's going to be opposite. So it's going to be positive. That means any equation that you create that uses the slope of 1/5 will work. It will be perpendicular to y equals -5x plus 8. So, Sophia, pick a sample equation that will work.
Y equals 1/5 x plus 2.
Excellent. Pick somebody else that's on the call.
Garrett.
Garrett, tell me another equation that'll work.
When I did this problem, I had y equals 1x plus 8.
Excellent. Yes. So it's y equals 1/5 x plus whatever you want to put. Any number here will work. If you're like Dylan, you can make it y
isn't it the
equals.
opposite?
What's that?
Isn't it the opposite? Don't you want to change the 1/5?
No.
Oh, oops, that problem's the same. Okay, yeah.
Yeah, you always want to keep the y and the x and the 1/5. It's this here where it crosses the y axis that you would change.
10.
So if you want to be somebody like Dylan and you want to have a really wacky number in there, you could have y equals 1/5 x plus 1,111,001 or something like that. And it would be true. It would be correct.
10.
All right, excellent. Is there anybody who has any questions about problem 9 before we go and move on to problem 10 then? I can't really see the chat from here. So if you do, you have to like unmute and tell me, or somebody else tell me that I need to read the chat. We're good? All right, Garrett, you get to pick the next victim. Who do you pick, Garrett?
Emma.
Emma, okay. So Emma, in problem 10 here, when we're trying to figure out what we're supposed to do, notice we have this different word. In problems 8 and 9, it was write the equation. And so we didn't have to do any figuring. We just had to understand the concepts. Here, we need to find the equation. The equation is not missing, but the equation is going to need to get figured out. So here we're going to have to actually do some math. And the information that they give us, the hints that they give us, are 2 different coordinate points, -3, 2, and 5, 7. Now we're going to be using that slope-intercept form. So Emma, can you tell us what the slope-intercept form looks like?
Y equals mx plus b.
All right. And then what are the 2 pieces of information then that we're going to need to do to turn y equals mx plus b into the specific equation of this line?
You have to put the numbers there, I guess.
Well, specifically, we need to find out what the m is, and we need to find out what the b is. So when you say put the numbers there, I'm not sure exactly what that means.
That's what I meant.
All right. Which one do we find out first? Do we find out the slope first, or do we find out the y-intercept first?
intercept?
Okay, tell me how you would find the intercept.
I don't know.
Well, I'll show you how to find the intercept from 2 points later, but let me suggest it's going to be a lot easier for you if you start with finding the slope. So if you want to find the slope, the equation that is slope is the difference in y points over the difference in x points. So put some actual numbers I can write down here. What would I write?
You put 7 minus 2 on top.
7 minus 2, because here's the 7 and there's the 2. All right,
And then
over.
you would put 5 plus 3 on the bottom.
Right, because it's 5 minus 3. So we might as well put that 5 plus 3. So 7 minus 2 is 5. 5 plus 3 is 8. This is our slope, 5/8. Now that you know the slope, how can you find the intercept? There's a lot of different ways you could do it, but tell me one way that you want to try to find the intercept.
Could you graph the points?
Well, we're going to try to do this one without graphing. Let me give you a hint. This is a value for x. This is a value for y. This is a value for x. And this is a value for y. You have an equation that now has the m filled in, right?
Mm-hmm.
You know one pair of x and y. You actually know two pairs of x and y. So if you do some substitution, then you would only have one variable left. The only letter that would be left in your equation would be the b, and you could solve for the b.
Okay.
All right, so what do you want me to write over here then?
Would it be 2 equals negative 3x plus b?
Well, 2 is this 2 right here,
Right.
equals 5/8 times, what's the x?
1.
No, it's right over here.
No, 3.
You have to stick with the same pair if you're going to do this. So what is it?
Negative 3.
Negative 3, there we go, plus b. So we have substituted using this pair of coordinates into this equation. So the y became 2, the x became the negative 3, although that negative's not very good. And now we can just solve for b. So Emma, tell me what to write next.
You have to do the distribution. So that would be 5/8 times negative 3/1.
All right. I'm going to go ahead and do the 2 there, so it's there. All right.
Negative 15/8.
Negative 15/8 plus b, right?
Yeah.
All right. We need this b all by itself.
You would add 15/8 to both sides.
All right. So plus 15/8 and then plus 15/8, although all of that's just going to become 0. So b equals 2 plus...
Except it's negative 15/8, and there is a difference. And that's important to note. Just saying.
Sorry, can you say what?
It's a negative 15/8, so wouldn't you add the other instead of,
Yeah, so we had negative 15/8 right here, and Emma got rid of it by...
Never mind, I see what you're saying.
She's adding the opposite.
I interjected before looking at it again. Sorry.
Oh, no problem. So,
My bad.
So, all right, Emma, we're doing this 2 plus 15/8. We need that to look a little bit prettier.
So it'll be 2/1, but you have to have your denominators be the same.
Yeah.
So it would be 16/8.
All right, so what you're doing then is you're multiplying this one by 2 over 2, right? So that you're going to have a common denominator. So you have 2 times 2. No, that's not what you want.
It's 8 over 8 times 2 over 1.
Thank you. There we go. 8 times 2 is 16 over 8. So these two turned into this. 8 times 2 is 16. 16 over 8 plus 15 over 8 equals what?
That would be 31 over 8.
31 over 8. All right, so this is your B. This is your y-intercept. This is your M, which is your slope. You are now ready to write your equation. You have found it. It is no longer missing. What should you write?
Y equals 5/8x plus 31 over 8.
Yes, and even though this is not like a pretty equation, because we have 31 over 8, you're like, is that really the right answer? How come it's not like 7 or something like that? This is indeed the correct answer. So Emma chose to, well, with a little encouragement, chose to find the slope first. And then after she found the slope, use substitution to find the intercept. If she had wanted to go the other way around and start with finding the intercept first, I'm actually going to go back over here because I will give extra credit if somebody can tell me a strategy that she could have used if she wanted to locate the intercept first. Does anybody have any ideas? But not graphing. Sorry, Dylan. This is just using the equations themselves. Because you're right. You could have visually put it on a graph, drawn the line, and then, you know, done some guesswork. No calculator either. Okay. If nobody has an idea, I will show you what she could have done. Oh, wait a minute. I see another note here. Well, it is one way. Okay. I don't recommend this method. I recommend that you find the slope first, which is why we have one slope and then two intercept. But if you wanted to, what we know about the y-intercept, about that b, is x always has a value of 0, right? And so what we don't know is this piece right here. So if we substituted question mark equals m times 0 plus question mark. No, that won't work. We still have two different variables here. We still don't know the y and we still don't know the intercept. So I take back what I said. You absolutely, without a doubt, cannot solve it finding the intercept first. You must find the slope first. Otherwise, you can only get partial information down here. So find the slope first. I was thinking in my head we were going to be okay because we would make a third point where x is 0, but we're not okay. That doesn't work. Now, if one of the points up top here had been 0 something, then we could have done that. Since we know the intercept is 31/8, if one of these points up here had been 0 and then 31/8, then you could have done that. Because you were actually already know it. It would have been right here. Okay. Any questions on 10? And is your understanding of 10 still a 10, or is your understanding starting to go down as we're getting a little more complex here? Is everybody good? If you're not good, say it right now. All right, Emma, pick a victim for 11. This person actually gets to graph.
Dylan.
Dylan. All right. Dylan, let's look at what we are supposed to do. By the way, Dylan, I didn't see you last week. How's your summer going? Hello, Dylan. Can you talk? And I don't know, are you Are you unmuted? I can't see. Oh, there you are.
Good.
Okay, excellent. All right, so this one is not saying to write an equation. This one's not saying to find an equation. This one is saying to solve a system. And you're going to do that, the how that it says, you're going to do it by graphing. So here, the graph is going to help you solve the system. We have two different equations here, which means we have two different lines. The solution to a system of two different lines, what it's asking for is, what is the intersecting point? So if one line goes this way and one line goes this way, what they're asking is, what is this point? Whatever it might look for. All right, that's what we're looking for. So you're going to have to graph the first equation and then graph the second equation. And then visually, you will use the graph to solve it. So y equals 3x. Now in our form of y equals mx plus b, what's missing in this first equation?
B.
B. And we said last week that when b is not part of your equation, like it's not right here, you are guaranteed that the intersecting point of that line on your graph is going to be the origin. It's going to be 0, 0, because if the place where it crosses the y-axis is 0, this is where it crosses. It has to be right there. There's no other choice. Which means for this particular one, you already have a piece of information that you could use because you already know a point. You know that one point is 0, 0. All right. Now, Dylan, if you know that this is the intercept, what is the slope of y equals 3x? This is the other piece, right? What is the slope?
So a 3.
Yes, 3. All right, what does that mean? That means if we write 3 as a fraction, 3 over 1, this part, the 3, tells us how the y-axis moves. Actually, I'll read it. So this is like the up and down part. And then the bottom part down here tells us how the x-axis moves. So this is the side to side, which means, Dylan, you don't actually have to add, you just have to count. So I'm going to go right down here to my origin point. Tell me where I go. Maybe make this a little bit bigger. There, is that a little bit easier to see? Okay, tell me where to go to draw another point.
So you go a 3 to the right and 1 up.
No, opposite. So the top is the y, so that's the up and down.
Oh.
And then the bottom is the x. So 3 up, and then 1 to the right.
Really?
All right, tell me where to go from here. Can you tell me another one? I only need 2 points to draw a line, but I want to practice plotting points. So tell me where
3
to go.
down and 1 to the left.
Yeah, that's that here, and 1. So 3 down, 1 to the left. Now the reason why this time he went up and right is because we can express this fraction as a positive fraction, a positive 3 over a positive 1. We can also express the same fraction as a negative 3 over a negative 1, because a negative divided by a negative is a positive. So these are two different ways that they look different visually, but they actually have the same value, the same meaning. So from here, I can go up 3 to the right 1, or I can go down 3 to the left 1, down 3 to the left 1. So now comes the task of me trying to draw a straight line. We all figured out I was not very good at that last week, but I will still try. Yeah, nope. Okay, so that is an ish line. I don't know why it's so hard to draw straight on the little pad here, but all right, something like that. Maybe I'll even try to just do a highlight of the lines here. Oh, thank you, Dylan. Was that you? So we have one line. Now let's go ahead and try to get our second line. So let me make this a little bit smaller while we look at the equation again. All right, Dylan, you can pick a different partner for the second part here. Oh, sorry, when I made it smaller, the line didn't work. So who is going to do the x plus y equals -4?
Who hasn't gone?
Jonathan hasn't gone.
Then Jonathan, I guess.
And Matthew, I think. All right, Jonathan. Hello, how are you?
I'm doing pretty good. How are you?
I'm all right. So this is what we're doing, this equation right here, this x plus y equals -4. Now, is that in the y equals mx plus b form?
No.
All right, that's the first thing you're going to have to do then is rearrange some things so it's in the right form. So let me rewrite it over here so we have room. Tell me what to do.
Subtract x from each side.
All right, minus x on each side means y equals -4 minus x. Now what do I need to do?
Then you can just switch -4 and -x.
Yes, we can just switch their location. So y equals -x minus 4. Are we now in the y equals mx plus b?
Yeah.
All right, so the two pieces of information that we need to graph are the b, which is the -4. What is the m in this equation?
-1/1.
Yes, so whenever you see something like a minus sign before the x in a y equals mx plus b, or even if you don't see a negative sign and you just see an x, you all should remember there is a number there. It's invisible. You don't see it. There's a 1 right there. So the slope in this one is -1 and the intercept is -4. All right, let's go ahead and draw a point then. What is the first point that I'm going to draw on our graph here, Jonathan?
Go down 4 spots.
Go down from the origin?
Yeah.
All right, and 4 spots? 1, 2, 3, 4. All right, so that's our intercept, the -4. Now, how do I get another point?
Use the slope from that point and go down 1 and over to the right 1.
Down 1, right 1, down 1, right 1, or up 1, left 1 for the same reasons, up 1, left 1. All right, that's enough for us to draw. Now you have the challenge of trying to see where these intersect. Thank you, whoever did that. I think that was Dylan. Dylan is pretty good at annotating. So we are looking for this cross section where they cross. What are the coordinates of that point, Jonathan, as best as you can tell?
-1, -3.
-1, -3 is exactly right. So when you write this formally, because this one asked you to solve, solution set equals, and then you have your little bracket there, -1, -3, and you close it and you circle it and you're all good. All right, that's the end of the first page. So is everybody doing okay? Does anybody have any questions on the first page? Anything that you don't like? I don't get this. We're all good?
I have one question. It's not on something I don't get.
Uh-huh.
It's on a question about 11. about technique. So on this one, it specifically said by graphing.
Right.
But say you didn't have to graph on it.
Uh-huh.
There is another viable method, and
Way
I'm
to
just
use it?
asking, would I be able to use it? Okay.
So yes, you are right. There is a better method than graphing, and we're going to actually sample one of those, I think, on our next page. Yeah, solve the system of equation, because you can graph, you can substitute, you can eliminate, and we're going to practice that in just a couple minutes. But for you to get this one right, you would have to do it by graphing, because that's what the directions told you to do.
Yep. All right. That's all I
If
was
you
asking.
did it the other way, I'd say that's the right answer, but the wrong method. Try again. All right, Jonathan, you get to pick the next victim. We are now on page 96 and problem 12. And
Matthew can go.
yes, yeah, I think that Matthew is the one that is ready to go here. So, Matthew, here you asked for something a little bit more challenging. We have the same instructions from before. So it was solve the equation, except these ones are not equations, these are inequalities. For those people that maybe were not thinking about this or didn't do the homework yet last week, the difference between an equation and an inequality is an equation is going to create a solid line. So if you have an equal sign, that's what it's going to look like on the graph. If you have a greater than or a less than, it's going to be a dotted line, and it's going to include shading, because it's all of the values to the right or the left or the top or the bottom of that dotted line. And then if you have a greater than or equal to or a less than or equal to, it's going to be a solid line, and it's going to have shading as well. So it will include all of the values on the line, but then it also includes all of the values to the top or bottom or right or left, depending on what you're doing. So in what you have to work with here, Matthew, one of your equations is that greater than or equal to. So that one is going to be the solid line, and it's going to have the shading. And then the other one is this less than. And so this one is going to have the dotted line and the shading. All right, so you get to pick your poison. Do you want to do the first inequality or the second?
Well, I can do them both right now. I've already done this problem.
All right.
I worked ahead a little bit. I'm sorry about that.
There is
So
nothing.
do you want me to?
Never ever apologize about doing your homework.
Do you want me to just put down all the points that I have for each of the inequalities and then write down the inequality I got at the end? Because none of them actually equals an equation in the end, unfortunately.
Well, let's work with the first one. Y equals greater than or equal to 1, and tell us what you did.
On that one, it's pretty much just common sense that you'd put a point on 1, on Y1, and then all the way up. Because it's only going one direction. It's not going both like a normal line is. And it's not ending off like a line segment. It's, what's that third one called?
Okay. So what you're saying is put a point right here.
And then one above it, another above it, and another above it, and so on and so forth.
Oh, actually, you're going the wrong way.
No, I'm not. Because it's greater than or equal to Y1, so you'd be going upwards. Because that's the point we're working with.
It goes this way.
Why would it go that way? This is Y, not X.
Y is always going to equal 1. So if you think of the, let's pretend for a second that it's not the greater. Let's just do an equal sign right now. If you think of Y equals mx plus b, and you compare, there's a Y, and there's a Y, there's a B, there's a B. What you don't have in this equation is slope or X. It never ever touches X. So This is the intercept right here on the 1. And I can make y x in terms of coordinates, any value. It doesn't make a difference because it's times 0. It's always going to become nothing. So this particular one is a solid line that is where y meets 1, but it never ever has an x in it. It never touches x. So it is a line that is parallel to the x.
Okay, I was taught a different method on how to do this.
Does what I said make sense?
It does.
Like, for example, if you don't think of it as an inequality, just think of it as y equals 1. Well, y equals 1 here, y equals 1 here, y equals 1 here, y equals 1 here.
Well, yeah, I get that.
Uh-huh.
But, yeah, no, I see how you do it, but during my Megas classes, I was taught a different way to do it, and I'm sorry about that.
No,
so
right.
I can do it your way from now on, but I did it my way and I got the right answer because I ran it through both.
Do you know how to do a screen share?
I don't actually have it pulled up. I have it on hard copy only. That's how I do my work.
But if you did a screen share to like a whiteboard, do you have the ability to annotate the online that you could show us?
Hold on, let me see.
Because I'll stop sharing and you can do a screen share if you want. We're always interested in different methods and ways to do things.
Yeah, sure. Let's see here. Open whiteboard. Don't know if I can.
So Dylan's suggesting you could turn your camera to it, which, you know, depending on how big your camera is, that works too. And then you could just.
I don't think that would really work for me, but I'm gonna.
Well, why don't I'm gonna go ahead and have someone else work on the second equation, and that'll give you a little chance to see if you could figure out how to show us later on. Is that all right? I'll ask you in a couple minutes.
Okay.
Okay. So we have points on this first line that Matthew did, but remember, this one is not actually an equality. We were pretending it was an equality to get our points, but it's greater than or equal to. So this one, because it's an or equal to, is that solid line, which I assume Dylan put on there for me. But because it's greater than, it's going to need shading. And so greater than is always top and right. Less than is always bottom and or left, depending on the line that you have drawn. If you just are not sure if you're supposed to be shading the top or supposed to be shading the bottom, our general strategy for checking is to use the origin point, because we all know it's 0, 0, and 0, 0 is really easy to plug into an equation. And we know, so here, let me do this. 0, 0, using the equation y is greater than or equal to 1. Well, if y is 0, 0 is greater than or equal to 1. That is a false statement. So that means this part down here is not the part that gets shaded. So you can use the origin point as a way of checking. All right, Matthew, can you pick somebody else in the group that will work on this second equation for us? I think everybody's gone once, so you can pick anybody you want.
Sophie.
All right. Sophia, you are doing this y is less than 2 plus x. And remember, we want it to be in the y equals mx plus b form. So you're going to have to move things around a little bit. Can you tell me what to write?
Would it just be y is lesser than x plus 2?
Yes, you just had to switch those positions because it has to be in the mx plus b position. All right. So what is the intercept for this line?
+2.
The 2. And then what is the slope for this line?
1/1.
Yeah, it's that invisible, I can't see it, but it's there. It's that 1/1. So we can go ahead and start graphing this one because you know your slope, you know your intercept. I'll make these points blue. I'm here at the origin. Tell me where to go to graph a point.
Up 2 points, like up on the y-intercept 2.
Okay. So 1, 2, there's a point. And then where is the next point that I can draw from here?
To the right 1 and up 1.
Over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, or down 1 over 1, down 1 over 1, down 1 over 1. Dylan, you're like ahead of me. Down 1 over 1. Thank you for drawing it in. All right, now this one, it's not the less than or equal to, it's just less than. So like Dylan did, it's that dotted line instead of that solid line, but because it's an inequality, it needs to get shaded. And less than is always below or to the right. So it's on the bottom. Let's go ahead and test with 0, 0 to see if Dylan is right. So if I test this part, that should be in the shaded part. So it should make a true statement, that 0, 0. So if I put 0 is less than 0 plus 2, 0 is less than 2, that is true. So we have shaded for the one equation, we have shaded for the second equation. Now it's asking us to solve. So when we solve, we are finding the intersection. The intersection here is not just a single point, it's which shaded areas are common to both. So it's this area right here on into infinity that is common to both. And this is why this particular problem is good to do in a graphing form, because you can write out a whole really long thing and not really understand, but visually you could see. So if your graph has this part here, darker, and when you do your shading on your own, sometimes what people will do is they'll do cross hatching for one, and then they'll do a different direction, cross hatching for another, and then where those two intersect, it looks like the checkerboard pattern right here. Do it in any way that you feel comfortable with, but that's how you would solve two different inequalities. You're going to find which part of this two-dimensional plane they share in common, and it's the part that is getting circled over and over and over there. All right, this problem 12 was a little bit trickier. Oh, so my annotation, or when I move this, your annotations are going to disappear. Let me come back over here. How are you guys feeling about number 12? Is it okay? Sophia says it's okay. Do you guys all know how to use your little participant buttons? I guess it's not a little, your reaction button. Yeah. So they don't have a thumbs down, but thumbs up is all right. Okay. Matthew, were you able to figure out if you can show us the other way you learned to do problem 12?
Yes, I believe I can. Hold on.
Okay. Go ahead and do a screen share.
I am attempting that now.
You guys are doing great. We only have 2 problems left for today.
Okay. Hold on. Oh, okay. I see. First time we've ever screen shared, so I have to grant permission.
It's all a learning process. All right.
Here, you need to go screen record. Done. Okay, there we go. Let's see. That's how you gotta do that. What's your pass? Oh wait, hold on. Should probably mute this part.
Are we close or should we come back to it? Matthew, I'm going to come back to you. Oh, wait a minute.
Yeah. Sorry about that.
That's all right. I think I'm going to come back to you, and then you and I can maybe work on it, and then you can show us next week. Is that right? All right. So now we are doing exactly what Matthew was asking about. He said, do we have to use a graph? Do we have to visually see the intersection of equations in order to solve them? Dylan, your hand is raised. Do you have a question? Hello, Dylan?
Why are there two Matthews?
Oh, I don't know. Maybe he's setting up something to try to show us on a different, tablet or something. We'll find out later. But Dylan, while I have you, why don't you work on this problem for us? So looking at what we need to do, we are solving just like we did before, and we have two equations just like we did before. But now the how it's telling us to do it, it's giving us a choice, but one of those choices is not graphing. It says we can do it by substitution or we can do it by elimination. Which way would you like to do it? To give you a little reminder of what this means, when you eliminate, you are getting rid of a variable. So, because we know how to solve equations with one variable. When you substitute, then you are solving for one variable in terms of the other and then putting that information in. So which way do you want to do it?
So can I write down like what I did?
You want to tell me what you did?
Yeah.
Okay, go ahead. Are you doing it in chat? I need to go back over here. Oh, that's Matthew's clone. So Dylan, are you going to say it out loud so I can see it? Because I can't see the chat while I'm doing a share screen.
So I was just gonna like type it in the thing.
You're going to type it in the chat? Because while you're typing it, oh, you're going to type it, you're going to annotate it on here. I see. So the last thing that I see is you typing here. Are you typing? Hello, Dylan. Dylan, I'm not sure what happened to you. I'm going to go ahead and use, oh, there you are. Okay. So 2x minus y equals 6, and then y plus 6 minus y. I'm not sure I understand what this is right here, the second part. All right, Dylan, you can keep typing down there what you're doing, and then we'll look at it when you're all done, because I don't want a big silence while you're typing it in. I'm going to show the elimination method, and then someone else can talk about the substitution method. But when you have two different equations, you can add them together. And so I'm going to add 2x minus y equals 6 to x plus y equals 6. And I just go down term by term and add. So 2x plus 1x right there is 3x minus y, which is the same thing as minus 1y, and plus y, which is the same thing as plus 1y. Those two are opposites. So whenever you add opposites, they turn into nothing. So that's like plus 0 equals 6 plus 6 equals 12. So 3x equals 12. X equals 4. Now that I know what x equals, now I can substitute that into the first equation. And so it's going to be 2 times 4, because that's what x is, minus y equals 6. 2 times 4 is 8. 8 minus y equals 6. Then y equals 2. And right there, that is the second part of what I need. So my solution set is 4, 2. And I came to that procedure using elimination. I used this method right here. I eliminated one of the variables. I eliminated the y. Once I figured out what x was, then I substituted to get the y. That's the one way you can solve this problem. Is there somebody who feels confident that could tell us how to solve the same system of equations, not using elimination, but just by using substitution? Anybody? Throwing out that extra credit challenge. Anybody?
I can.
All right, who is I?
It's me.
Is me Garrett?
No, it's me.
Me Matthew?
Yeah, that's me.
All right, Matthew, tell us how we would do it with substitution.
Okay, so we would take our basic equations.
Yeah.
Which is 2x minus y equals 6, and then x plus y equals 6.
Yeah.
The best way to do it would be to take the second equation and subtract x from, or subtract y from both sides. Would be the best way to do it.
Minus y, then we get x equals 6 minus y. Gotcha.
And then we would take the first equation and we put it in as 2, and then multiplied by 6 minus y, and 6 minus y in parentheses, obviously.
Yeah,
and then we
change colors here. 2 times 6 minus y. All right.
And then we would get minus y.
Yeah.
And then equals x, or equals 6.
Equals 6.
So
Great.
we So then we distribute the 2,
Yeah.
and we get 12 minus 2y equals y. But we can simplify that.
Y.
Yes. Yeah. And that equals 6.
Uh-huh.
And then we can subtract the 1y off of the 2y and get a 1y.
Well,
We get
no,
12
minus 2y.
Oh,
minus
right.
1y.
That's a minus. Yeah,
Yeah.
okay. Yep. Sorry, algebra,
Right.
not normal math. Is that in a negative 3y because you'd add 2 negatives together and you get a negative 3, so it's
Exactly.
yeah.
12 minus 3y equals 6.
Yep, and then you get equals 6, and then you divide by 3 on both sides, and you get a.
Well, we can't do that yet. So from
Yeah,
right
you're right.
here,
We have to do the other first. That's right.
Yeah.
We would subtract 12 off of both sides and then divide by 3.
All right, minus 12 on both sides gives us minus 3y equals minus 6. And then what do?
We divide by negative 3 on both sides. Excuse me, not 3.
Right. Divide
And then we get
by negative 3.
And then we get 2, or then we get y equals 2, and then
Y
we just substitute.
And so
Then we just substitute x plus y, the for second equation back in.
Right. So this way works. The way that Matthew did it is going to give us the exact same answer. It's going to give the answer of the solution set of 4 and 2. The value of x is 4. The value of y is 2. And if we did this on the whole graph thing, this is that point where those 2 lines intersect. So for those of you who want to see the relationship and want extra credit, what's a good extra credit color? Orange. This problem here, problem 13, for extra credit, if you want, go ahead and graph those and find the intersecting point using the graph. So if you want to get the extra credit on this, that means you're going to have to add in a different piece of paper. You're going to have to put on a graph with all of the things. You're going to graph the 2 lines and then show that intersecting point. Does everybody understand what I just said? Yes. All right. Is there anyone who does not understand how Matthew used the substitution over here to solve this system of equations? We're all good? Are we like, I understand it like a 10 good? Because if we are, we're going to get done early today. It's 1:45 and we have 1 problem left. Matthew, pick somebody to do our final problem for us.
Okay. Who do we got? Dylan.
All right. Oh, actually, Dylan's gone twice. Can you pick somebody else?
Garrett.
Great. Thank you. So Garrett, I kind of wrote over the problem. I'm just rewriting it down here in the orange. This is not a system of equations. It's a single equation. And we look at what it wants us to do. It wants us to solve, which means we have to find out what is the variable, what is the answer. Our variable is x. You are solving for x. When you are trying to remember how to solve for a variable in algebra, the dance like people and zombies are outside is the acronym that we remember. D stands for distribution. L stands for combining like terms. P stands for if there are placeholders on both sides, getting them to one side. Z stands for making zeros, so the things that we can get rid of by using addition or subtraction. And then the O stands for making ones, the things that we can get rid of using multiplication or division. So, Garrett, what do we want to do first? First of all, let's take a look. Is there distribution to be done? Distribution is when you have parentheses and something out here that you need to pass out.
Yeah.
The parts that are here and here. So do we have distribution?
Yeah.
Yeah, we have distribution
8x
right here and also distribution right here. So tell me what I should write.
8x.
Yep.
And then plus 8.
Plus 8 equals
5x minus 10.
Right? So once you distribute, the parentheses disappear. Plus 1. All right, this part is done. Do you have like terms on both sides? I mean, yeah. Do you have like terms that you combine? That's what I should have said.
On the two different sides of the equal sign, yes.
Yeah, what I meant to say is right now, can you combine 8x or 8?
No.
No. Can you combine 5x or negative 10 or 1?
The negative 10 and positive 1.
Yeah, so these are like terms. We're going to go ahead and combine those. So 8x plus 8 equals 5x minus 9. All right, that was our like terms. Now, this is what I said before. I didn't mean to. Are there placeholders on both sides? So do we have our variable on both sides?
No.
Actually, there's an x right here.
Yes, yes.
And there's an x right here. So we do. So this step in solving says we want to combine, because we only want a single x in our equation. And the way that you generally combine is you take whichever one is the smaller one, and that's the one that you decide to get rid of. So between an 8x, yes. How are we going to get rid of this 5x over here?
Have a negative 5.
Negative 5x
So
on both sides.
3x.
All right, so when we do that, we have 3x plus 8 equals negative 9. So you did the placeholders. Now we are trying to get this x all by itself, which means the next thing that needs to go is this 8. We need to turn this positive 8 into a 0. How are we going to do that?
A negative 8.
Yep, on both sides. You always have to do everything on both sides. So then we have
negative 17.
Yes, because you have negative 9 plus negative 8. That's negative 17. All right, we did that part. We're down to the final part. We need to make ones because we don't want 3x. We just want x. This 3 has to turn into a 1. All right, so there's two ways you can do it. You said divide by 3? Yep, some people will do it by multiplying by negative 3. Those are two different ways of saying the same thing. Either way, x equals negative 17 over 3 is the answer. You have solved for x. So once x is all by itself, whatever is on the other side of the equal sign is your answer. And then that's it. All right, I'm coming back. You all need to get back on camera just for a second. Is there anyone who wants to review any of the problems that we went over today or do a similar problem from problems 8, 9, 10, 11, 12, 13, or 14? Everybody's good? Okay. Does anybody have any questions about the extra credit movie assignment or how to get into Slack or how to use Slack or how to upload your assignments on ThinkWave? No. Great. Then yes.
What was the answer to 12? I just wanted to test if my method actually works, and if not, I was gonna redo it the other way.
Okay. What I think we'll do, Matthew, is we'll let everyone else go, because I also want to see if we can figure out the share screen thing with you. Is that all right?
Okay.
All right.
Yep.
So everyone else, check out. I will see you next week. You have a week to get your homework in, these 2 pages, but feel free to turn them in right now. There's nothing wrong with that. And